Okay, today we're going to do a breakdown of the Tesla Powerwall 3. So the Tesla Powerwall 3 isn't just the battery that you see hanging on the wall. It's also a handful of other products that they've got that work as an ecosystem together. So we're going to explain to you all these different components. Then we're actually going to break it down. As you can see, we've got the lid off it, and we're going to look at the internals of the battery, explain what is actually going on inside there, and we're going to tell you what we like about the build of it, but also some things that we're not terribly impressed with.
Speaking about breaking it down, we've had a few breakdowns as well. So look, it's been a pretty high percentage, and I wonder if it's worth continuing to sell Tesla.
Yes, we've had a bit of a debate about that, and I think we should talk about that as well.
All right, let's get into it.
Okay. Okay, Yorick, tell me about the Tesla Powerwall 3. What is it?
Okay, so the Tesla Powerwall 3 is both a 13.5 kilowatt hour battery and a solar inverter all in one.
Yeah, okay. And so what size inverter is it?
So it's actually an 11 kilowatt inverter, but it's actually software locked to either a 10 or a 5 for the Australian market. This is for our requirements.
Yeah, so the same product, we can either decide to call it a 10 kilowatt or call it a 5 kilowatt, depending on whose house we're putting it on. Right?
That's correct, yes.
Okay, what about MPPTs and stuff like that?
Yeah, so there's a few little changes for the Australian market. So we need an internal DC isolator. So we get 3 MPPTs or 3 solar inputs instead of 6 that they get in other markets. But these are much higher current inputs on the Powerwall. So it still gives us really good design flexibility.
Yeah, exactly. Now, that little baby Powerwall that you see hanging on the wall at head height, what's that called?
The gateway. So yeah, it still uses the same gateway as what it was for the Powerwall 2. This is essentially the consumption meter for the Powerwall system. It's also the islanding contactor. So when we go in off-grid mode or in a blackout, it's what breaks your off-grid. It's a vital component of the Powerwall ecosystem.
And you mentioned that it's a 13.5 kilowatt hour battery.
Yeah.
That's pretty small these days.
It is.
So what have they done?
So what we now have are these expansion modules. So we can add it, which look almost exactly the same, except there's no inverter in it. And we can bring the Powerwall from 13.5 to 27 or 40 or even 54 kilowatt hours worth of storage.
And EV charging too, it's got EV charging built into it. So if you've got a Tesla Powerwall and a Tesla car and a Tesla EV charger, the EV charger now turns into a solar surplus charging. So it only uses solar power to charge your car. Right?
That's correct, yeah. And you can actually link your wall connector to your Powerwall system. So on the one app, you can see what's going to the house, what's going to the car, what's going to the grid. It makes for a really nice ecosystem.
It is, yeah. And that's what I've got on my app at the moment. I don't have a Powerwall at home, but I've got your Powerwall, my car. I've got a whole bunch of things. It's really a user-friendly sort of situation there, isn't it?
I really like the app, hey. And I think that's one of the things that, look, they're an industry leader when it comes to the app. It's minimalistic, but a lot of companies copy it. I really like their Stormwatch functionality. So if there's a predicted blackout, it will automatically charge my batteries.
That triggered for yours and the office here just the other day?
Yeah, we had a severe weather warning. No blackout, but it's definitely came in handy nonetheless.
So what it does is it charges your battery up, because it thinks there's storms coming on Friday night, so it charges it up to 13.5 kilowatts, sits it there just in case you have a blackout. Pretty cool.
Pretty much, yeah. Look, the other thing I really like about it is that its time-based control is really clever. We've compared it to some other brands as well, and it takes into account not only your historical usage and learns sort of what your usage habits are, but it takes into account the weather forecast, and it will charge and discharge the battery to try and save you the most amount of money. It's a little bit different to their self-sufficiency mode, but their time-based control, I think, is very clever.
We have tested a lot of batteries now, and we are continuing to test a lot of batteries to review them. There's no doubt, I think the Powerwall is the best app in terms of user functionality, but also just all the little sort of AI kind of touches to it, I guess, or weather forecasting and stuff.
Yeah, Tesla is first and foremost a software company, and it really shows in their user interface.
Speaking of that, they keep on developing their product, and they've done a few changes. What's new about the product?
Yeah, so there's a few little things. Like with a lot of Tesla products, they get better with age. So, with a software update, you'll get more functionality or slightly better performance. And actually, one of the big improvements we've just had is with the expansion modules now, we go from a 5 kilowatt charge rate now to an 8 to about 11 kilowatt charge rate, depending on the number of modules you've got.
And just this morning, you were calling up the Sparky, seeing what they thought of installing the Tesla Powerwall. They told you there's a little bit of an update there too.
Yeah, so look, basically since we first started installing this particular model, there's been changes to the installer interface. It's much more of a seamless commissioning process. I know this is not something the customer sees sort of forward facing, but it does reduce the labor associated to jobs. Also, from a servicing standpoint, we get a lot more information from the Powerwall than what we used to. And this is not the customer facing side, but this is from us as an installer being able to help with any warranty issues that might arise.
Mm-hmm. Yeah, the version before this was the Powerwall 2. Fortunately enough, a couple of months ago, we ripped one off and tore it apart. And there's a cell sitting there.
Yeah, we've got an 1870 cells. Yeah.
The good news, bad news for that customer, but the good news going forward or soon, that will be backward compatible. So we'll be able to leave the old Powerwall 2 on there. This one was like 9 years old anyway.
Yeah.
And we'll be able to put a Powerwall 3 and they'll talk to each other. Right?
That's correct, because there's a lot of Powerwall 2s on the market, and actually it makes it very difficult if you want to expand it now, because Powerwall 2 is discontinued and you can't buy a secondhand one and install it. That is actually illegal. Yeah.
You're telling me this morning about PowerShare. I hadn't heard of that before.
Yeah, so PowerShare. So while this isn't available in Australia yet, I suspect it will come soon. If you have, say, a Cybertruck or maybe a Performance Model Y, these have vehicle-to-load capabilities. So if you've got a gateway and you're in a blackout, so you're not connected to the grid, it can actually pull power from the car through the Tesla wall connector and supply some of those emergency circuits. So you don't need a Powerwall 3 specifically, but it will basically interface with your battery, your home, your car. It's basically vehicle to house.
Yeah, that is a pretty cool setup. It's a massive battery in case of a blackout.
Yeah.
Driveway.
Yeah.
3-phase, right? Is coming. It's already in Europe. So this is a single-phase battery, right?
That's correct. Yeah.
So you can install this on a 3-phase home. You never would.
No, look, we can do it, but it's very limited. We have to lock it to 5 kilowatts. It backups only on 1 phase. I wouldn't use it on 3 phase myself.
Yeah, but maybe I'm guessing 20% of the houses in Australia are 3-phase. The larger houses with your big ducted air conditioning and stuff like that.
Yep.
In Europe, they brought the 3-phase out, and maybe in the end of the year, we'll have the 3-phase, whatever they call it.
Yeah, so they've done that.
Or whatever.
Yeah, no, exactly. We don't know what's going to be called, and we know that it's going to be a very similar type of configuration, so there's not going to be radical changes in the design, but yeah, look, it's been officially sort of unveiled. We've got a little bit of a sneak peek at it, but hopefully we'll have...
It's been a highly anticipated part of their lineup, I think, isn't it? So, yeah.
Now, I think a couple of things a bit closer to home as well. One thing that I think is important we've now got for the Energix system is dynamic compatibility. That's going to be here very soon with a software update, so no need for additional hardware.
Yeah, which just allows us to, the short of it is allows us to put Powerwalls in more homes without Energix complaining that, or whatever.
Correct, yeah. And also a little bit closer to home again, MC Electrical's now a premium certified Tesla partner.
Oh, that is an update. We had that meeting last week. He came in and congratulated us, and actually I just got the email with all the logos and stuff like that we can use. So we're a premium partner with Tesla, so that's cool.
Whatever that means. So let's have a look at the build of it, Mark.
Yeah, okay. So if you want to grab that, so on this side here, we have a DC isolator in the Australian market, okay? So that's only for the Australian market where we can switch up the DC, which is the power that's coming down from your solar panels. And that goes into these DC inputs here. The cables go in here. There's plenty of room for cable management, designed by installers for installers, as they say. So it's a nice, easy product to install.
Big improvement over the older model as well.
Yeah. It's so much easier. So in the US, this was originally designed as 6 MPPTs, which is total overkill. I don't know why you need 6 MPPTs, but they've only done 3 here. Why is that?
Yeah, so one of the problems they faced was that they couldn't get a 6-pole DC isolator that was compliant. So what they did instead is that we've dropped to 3 MPPTs, so 3 separate strings, but these are high current strings. So we can put panels in parallel. It's actually incredibly flexible for the design.
Yeah, and so what it means is you can have different arrays of panels in different areas, 4 panels here, 12 panels there, 6 panels there, whatever you want.
Or it is better, we can retrofit using an existing array that's up there, put in the Powerwall 3, and then add extra panels onto that third input that we haven't utilized.
And because of that high current, we won't go into it, but it just makes it, as you said, extremely flexible. You can make this work with any kind of panel.
Especially with old furnace systems as well.
Yeah. So DC then goes into, and this is the inverter. So remember, we've got a solar inverter in this as well. So that's your solar inverter that just obviously changes the DC power and inverts it into your AC power. It's a pretty simple inverter. It does have AFCI, which is arc fault circuit interruption, in case you have a problem. We've actually had nuisance tripping with that, well, at least
but it doesn't have the 4-wheel drive global MPPT tracking.
4-wheel drive, as I call it, or a gearbox. So yeah, honestly, if you've got a kind of relatively shady situation, you're just talking to a customer before we press go about one of those customers, you wouldn't put this system, I don't think, in a shady situation. That's where Fronius shines, I guess.
I don't think so as well. Yeah, I agree on that front.
Okay, so we'll go up here, over here, out, you've got AC out. So this is where it connects to then your switchboard. So heaps of room again there for cable management. They've really done a good job of the design. Up here, this little fella opens up like a taco shell. And
I'm getting hungry, Mark.
And you know what they call it, Yoz? They call it a taco.
Yeah, they do.
Because it looks like a taco. Very clever.
You know, I love a bit of guac in my taco, so this is something we need for our local market.
Yeah, so taco is just a communication device. This is what Energex needs to disconnect the battery from the grid in case of a catastrophic event like a power station blows up or we disconnect from the national electricity market or something like that. Yeah, so of course, because Elon Musk is hilarious, he called this a taco and that guacamole or a guac. Okay, now, Yoz, tell us about, this black section here, cooling. Tell us about that.
Yeah, so this is actually an actively cooled inverter and battery system. And we've gone on a bit about active cooling in inverters in the past. It's one of the things we really like about the Fronius ecosystem. But basically what we've got is, because it's a big inverter, we've got lots of fins here. And so the Powerwall 3 sucks air up through the bottom, through these fins, and then vents it out the back. But it also pulls air up through the back of the battery and then pushes that through the remaining of the expansion packs if they're behind it. So, yeah, it is an actively cooled inverter and battery system.
Speaking of that, there's two big fans there, and they make a bit of noise back.
They're giving Fronius a bit of a run for the money. I mean, the Gen 24 has been pretty good, but this is a noisy machine. It really caught me by surprise when it was.
Not that annoying, piercing sound of a snap, but it is loud. We've actually got one down in our showroom, and every now and then, if we're discharging it fast, it starts to scream, basically, So you've got to be aware of that. Yeah, it's no big deal. There's nothing going wrong with it. Now, obviously, the battery part of it, where is it? They've crammed it all in.
So it's in here and in behind here. So it actually is only maybe 2/3 of the thickness of the actual battery pack.
Yeah, and not even the full height of it, because you've got all this space up here. So they've crammed in a lot of different cells, and that's what you've got sitting on the desk.
Yeah, let's have a little bit of talk about it. So, look, one of the things we always get asked about batteries is, what is the chemistry that they're using? Well, the old Powerwall 2 was these NMC or nickel manganese cobalt cells. These are basically the same as what we have in like a Performance Model 3 or maybe a Tesla Model S, nickel manganese cobalt. One of the big improvements that they made with Powerwall 3 are these lithium iron phosphate cells. Now, they're pretty heavy, so not great for if you want to accelerate really fast, but they're very thermally stable. Now, these are pretty big cells. We were able to do a little bit of deduction based on the internal voltage that's on the spec sheet. We reckon there's about 26 of these 170 amp hour cells in a Powerwall 3 or the expansion model.
Yeah, it's set up perfectly to our 14 kilowatts total capacity and our 80 volts, because if you get 26 of these and multiply it by 3.2, you're around about your 80 volts, which is roughly what the voltage of them works out to be. Yeah.
So that must mean we have a DC to DC converter built into it. I thought we were very anti DC to DC converters.
Yeah, we kind of are. So Fronius, if you stack it correctly, you'll get up near the 400 volts just naturally by stringing all the panels together. That's a high voltage architecture.
Yeah.
All those other batteries that we are not so much fans of, even EcoFlow, Anchor, Sig Energy, Huawei, they've got DC to DC converters in them, and quite often they're stepping them up from as little as 25 volts or even less up to 450 volts.
That's quite, or 800 volts in some cases. That's a pretty big jump.
800 volts.
Yeah.
So this is not doing such a step up. So you would think, our theory would go that it's not going to lose as much efficiency because of that step up in the voltage, right?
Yeah. And we've been doing some round-trip efficiency testing. We've actually got the Fluke we've been using to do that on the table here. What are the results that we found? Yeah,
so we've done these numbers in a lot of videos, but we're going to add in the Tesla figures, obviously, this time. So high voltage batteries like the Fronius and BYD and whatever, they run around about 90% efficiency when, in best case scenario, best case scenario is when you charge it up fast. That's what you do in the morning when the sun comes up. And when you discharge it really fast, which actually doesn't really happen.
Unless you're part of a VPP.
Oh, maybe, yeah. Or at dinner time, you're discharging it fast for a little while, right?
Yep.
So 90% efficiency in that case.
Okay.
If I compare that to those other DC to DC converters, EcoFlow, iStore, Sig Energy, yada yada, that's a lot less.
Yeah.
smack bang in the middle of there, as it turns out to be, that's where Tesla sits. So they fit at about 84% efficiency on our round trip.
Very similar to Franklin, for example.
Very similar to Franklin, exactly, yeah. So kind of nice that our story is making sense to us, right?
Yeah.
Now, we did probably a more realistic test on all these batteries too, and we charge it up fast because that's what the sun's going to do mostly in the morning.
Yeah.
Not at full capacity when it starts up, but, get fully charged by 11 o'clock in the morning. We discharge it slow because that's what's going to happen overnight when your fridge is just running.
Sure.
So a 10 kilowatt inverter, we discharge it at 300 watts, which is pretty slow, right?
Yeah, it's a fridge, a TV or something. Yep.
Yeah, so the best case scenario and the worst case scenario, add them together, and with the high voltage battery, we get 80%. With those low voltage DC to DC converter watt batteries, we're getting sort of around 60, maybe 63%, which is pretty bad.
Yeah.
And with Tesla, again, basically smack bang in the middle at 70% efficiency. So
70%. Yep. Still not great, but
it's not great, but it's sort of a trade-off, I guess, right? So I guess the problem we've got with this architecture, it's kind of clunky. You've got two different components, even though you've got a gateway with it as well. It's not as elegant and crammed in one nice little unit. So they've kind of had to do a little bit of a trade-off there. And so speaking of that heat, you've mentioned earlier the fan cooling. I think that is part of the trade-off too. We've got these noisy fans, but that's what you got to do when you cram all this stuff into a really tight area. The reason they use larger cells is you've got more energy density in there.
Correct.
So you can put it into a smaller footprint.
Yep.
But as a result of that, you've got more heat with the DC to DC conversion, and then you have to cool it. So I think they've actually done a pretty good job of it.
Another really interesting that Tesla have done too is we were talking about charging slowly or charging fast and discharging slowly. It's interesting that their maximum charge rate is actually lower than their maximum discharge rate.
Yeah, so normally batteries do they call it 0.5 C. So it means they'll charge at half the capacity of, let's say you have a 170 amp hour cell.
Yep.
If you run that 170 amps through that, that's 1 C. If you do, what's half of 170, 85 or whatever.
Yeah, about that. Yeah, 85.
So if you run 85 amps through it, that's half C.
Yep.
This is running something like, I don't know what it is, 60 amps through it or something.
Oh, it's about, but I think it's 0.35 C. So it actually, it does charge quite slowly compared to some other brands.
Yeah.
But I think there's a good reason for that.
Yeah. So what they're doing is when you're charging, I'm going to explain to you, when we were over in China recently, we went to REPT Cell Factory.
And we made some cookies.
It was a penny drop moment for me, right? Because you sort of hear about all this in theory, you see some YouTube videos.
Sure.
And I thought, well, this is exactly what we saw. On one side of the factory, we saw an anode of the battery getting made, which is basically this big piece of aluminium foil that they paint, we'll call this a cathode, right?
Yeah.
They paint the LFP, the lithium iron phosphate on.
Correct.
So it's basically just a painted on surface onto, and this is called the collector. So this is kind of like the positive terminal.
Okay.
On the back side, you actually have a copper. Didn't have copper aluminium foil, and they paint that with the
like graphite, which is the anode.
Yeah, so that's the anode or the negative side of your battery. So if you connect the positive and the negative together and you put a light between that, this one won't work because it's only aluminium foil. In the middle, in the middle, you've got the separator, right? So I'll just use baking paper.
Well, Mark, it's not about the size of the battery, it's how you use it. So actually, when we were at BYD last year, we actually got a chance to make a little battery cell, which has got exactly the same components in it. And I think I might actually have a little bit of copper on here as well. But yeah, essentially, you're bang on. You've got the separator, anode, cathode, it's falling apart. But
and so we actually hand wound those like we're on a sewing machine because that's what they did in the mid 90s.
Back in the day,
they originally made before automation. But anyway, it was pretty cool to see it on a much bigger scale. The aluminium foil and the copper foil was much wider. It was so thin. It was like 100 meters long, and we were watching it on the left-hand, right-hand side. But anyway, that was all exciting. But what happens here is the lithium ions, ION, leaves when it's charging and goes into the graphite here.
Yeah.
So it goes into there.
And it has to sort of disperse throughout it as well.
Yeah. If you do that too quickly, you get lithium plating. Well, you actually get lithium plating anyway.
A little bit is good. Yeah.
But the faster you charge it, the more lithium plating you get. And if you get like a plating, like another paint surface over that of lithium, every time you do that, the more you do that, the more your battery is degrading because you're losing those lithium ions that kind of do the work.
And also the internal resistance gets higher as well, which would also generate more heat with time too, because it is an insulating layer.
Yes, it is. Yeah. So the point of charging it slowly is so that we don't have that lithium fating, so we don't degrade the lithium part of it as quickly. By the way, while the lithium ions are going through this way, the electrons go through the other way, and that's what makes your light bulb work.
Right. Yep.
So now the other way around, when you're discharging, the lithium ions are going from here back to the cathode.
Into the phosphate material, yep.
And you know what? It doesn't matter how fast you do that, really.
Yeah, and that would be why you charge cars slowly, but you can really floor them.
Exactly. You can floor the Tesla, but yeah, exactly. You can't charge it as fast as you discharge it.
Yeah.
I mean, you do still get heat degradation when you discharge it fast.
Yep.
And that's why, obviously, Tesla have thought about that. When you're discharging it at 10 kilowatts, those fans start screaming. They suck air all over it, and air flowing is a really cool way of cooling down the batteries, So
yeah, well, any form of convection will help. So no.
Hey, can I show you how this works afterwards? You sort of showed it over there.
Yeah, of course, yeah.
But I'm going to start going to battery manufacturing. Basically, they roll it up like this then, and they call that a jelly roll.
You're making me hungry, Mark. I reckon
they whack it in a can, bam.
And then we add some electrolyte.
Oh, mate, seriously.
Electrolyte, it's what batteries crave.
It's got electrolytes.
So, yeah, they put Powerade in there. No, what is it? Yeah,
It's Powerade. No, it is an electrolyte.
What's else be Powerade?
Yeah.
So basically, that is a nice one, Niels. That's how a battery is roughly made.
Yeah.
So you kind of threw me there. What are we on to next? So I guess the point of that all is that there is just a real trade-off.
Yeah.
They've made that form factor really tight. They've used really energy-dense cells, not the 320 amp hour cells.
They're like a nice intermediate between what we see in, say, BYD or other brands.
Yeah, to do that, they've had to put fans in there, which some people, I don't know, you hadn't had any complaints about fans, have you? I haven't heard.
Not particularly, but it did catch me out by surprise at how noisy it was when he first installed.
They are noisier. I would say noisier than the Fronius snap inverters, those old snap inverters.
Yeah, well, Tesla have to beat Fronius at their own game. Well, they do make a really nice looking battery, but is it a reliable battery, Mark? We've installed a fair few now. I think we're almost 100.
It's 90 actually today. And out of those 90, we've had 9 failures.
10%.
10%. It's not actually failures. So let me roughly go through it, right?
Okay.
By the way, and we've done 30 of those expansion packs that you're talking about, the battery only.
Sure.
We've had 2 of those fail. That's getting close to 10% as well.
Yeah, okay.
So one of the failures was a DC isolator. That switch failed. I've heard other people in the industry have that issue.
Okay.
One is that AFCI, that arc fault circuit interruption.
Yeah, okay.
That did nuisance tripping, so we didn't have to go and replace that.
So that's a software glitch, basically.
Yeah, and that's going to be pushed and fixed. Like AFCI is notoriously glitchy.
Yeah.
And to be fair to Tesla, Fronius still haven't turned the AFCI on by default in the inverters.
Because of the nuisance tripping.
Because of nuisance tripping. So that's a little bit unfair. Maybe we can take that back to 8 straight away. We've had 2 DOAs.
Okay, dead on arrivals.
Dead on arrival, so we go to install and it doesn't work, which is just a pain in the neck.
Yeah.
But that's not a fault. I don't know if you...
it's part of the commissioning process, but still not
to be fair, one of those is that we had an American taco. We don't like American taco. As if you know guacamole.
Oh, I like our locally made tacos, thank you.
And this is a concerning part that really threw me. So a lot of those you don't get too concerned about.
Sure.
So maybe 10% is a little bit harsh.
Okay.
But we've had 4, I believe it is, that have failed due to lightning or surges during a storm.
Yeah.
So we know it happened when a storm was happening. There's lightning around.
Sure.
But mate, this is supposed to be a backup and a blackout. Like this is supposed to protect you in a storm. That's how it's advertised.
Yeah, that's really, really not good.
They are working on that a lot. We are also installing a surge diverter in the gateway of every job that we do now to keep a chance on that.
Yeah.
They're going to get to that. What the annoying part about this is they were saying, which is kind of fair, if lightning destroys your computer, it's not the computer manufacturer's fault, right?
No.
If it destroys a Powerwall. But just the number, I don't think we've had a single, or maybe we've had 1 or 2.
We've done thousands of Froniuses.
So 7,000 or something like that. So it just seemed odd. Other friends in the industry I called up, they had the same issues. So I called up a bunch of mates in the industry. They agreed with my kind of rough idea of these faults are getting far too high. We did a group email, or I copied them into an email to Tesla, just to make sure I want to make myself be heard. Tesla heard us.
Yep.
They came back, a little while later, and they'd gone through all the faults. They explained everything to us. They convinced us that they were working on the issues. To be honest, after that, mate, you and me were over in China checking out all these other batteries, and we were trying to decide, do we get rid of that? If it was SunGrow, when back in the SunGrow days,
Yeah.
we got rid of SunGrow, and they probably didn't have 10%.
No, it wasn't. But yeah, look, it was this one thing that was going through my mind is like, if this is going to be a continuous issue, that is not the level of what we would accept from any other brand. But why do we accept it from Tesla?
Yeah, so I guess that's the difference, mate. And I think that's a big thing that we look at when we're doing all these product reviews. There's so many new batteries coming into the market.
Yeah.
They just haven't proven themselves, not only in the reliability, but if in the backup support. Are they going to disappear if they have 10% of their products fail? Tesla also had a lot of their Powerwall 2s recalled, and that would have cost them a mint.
Yeah.
But we know they're not. They're not packing up and leaving Australia, right?
And they were very proactive about it. And this is the thing, we were thinking about leaving Tesla, but it was actually our service manager, Shane, who convinced us to stick with them because he thought their processes were so good and he had the confidence in their warranty department.
Yeah, and I thought that was important. It was actually Shane that suggested that we leave SunGrow at the time because he was frustrated and didn't have confidence in them.
Yeah.
By the way, we've done a video earlier already. We have faith in SunGrow now. We think they're a great company. Things change, right? So
Nothing a little trip to China doesn't fix.
Yeah.
Elon Musk, wink, wink, nudge, nudge.
Or Nevada, that would be good.
Yeah.
Anyway, so we've kind of decided, I think the short of it is that Tesla is a product that you can trust. You might have your own opinions about Elon Musk. We put that aside. The engineering is different.
We don't sell it because of Elon, but we sell it because we still think it is one of the best batteries on the market.
And there's nothing really that would replace this. We're kind of thinking, what else? If we took this off,
it's very hard to find a comparable unit that would replace it for the needs that we have as an installer.
And probably most importantly is I've got faith in, I don't love running around doing warranties, even though they pay really well for their warranties. That's not what we're supposed to be installing batteries, not repairing them. And
correct.
But I do have faith that they're going to improve their processes and they're going to look after our customers.
Well, Tesla are known for innovating. They're known for doing, model updates, intermediate model updates. Who knows? Probably the units we're getting now have already got hardware improvements that they just don't tell the industry about.
I don't know if I mentioned, but with this lightning issue, there was a point where you go, on under warranty, and you can't. And I think there's a point, especially when I pointed it out to them, how many failures we're getting. They decided, okay, we're just going to do a goodwill thing.
Yeah.
We don't know whether it was actually reasonable that it was damaged by lightning or not, but we're just going to say we'll replace it.
Well, they didn't blame you as an installer.
Tesla, we're talking about Tesla, but that's else like that. So yeah. Anyway, let's wrap it up, yours.
Look, I only had one little thing to say as well. Is look, I really like the expansion packs. I think they work really well. We do have these cables that have to connect them. I think they're just a little bit too long. So a lot of feedback we've been getting from our installers is the 1/2 meter one is just a little bit too short if we want them side by side. But the 2 meter one is really quite long. So one that would be maybe 75 centimeters or a meter would be perfect. And I reckon we'll sell those like hotcakes. But other than that, I still think Tesla's a really good battery.
Yeah. So to wrap it up, I guess I'm comfortable with continuing with the product. I think you're comfortable.
I am as
a company. We're comfortable with supporting them, even though we've had some hiccups.
Yeah.
I would be interested to know, though, other installers. Give us your comments down below.
Yeah, wow.
What are you thinking? You reckon, you're gonna hang around? You're gonna bail? Be interesting to know.
And I think another thing is, let's have a bet. How big do we think the Powerwall 3 inverter is going to be? Is it only going to be the one size, or are we going to have multiple sizes?
I don't know. I reckon if you looked up in Europe, we could have find that out. We'll see. Anyway, thanks for watching, and we'll catch you next time.
Catch you next time.